All right, for today we have a very exciting demo I call the iron wire demo. Well, as you might be able to guess, this here stretched across this Frankensteinian arrangement is an iron wire. Well, actually, it is a steel wire. But steel is a ferrous metal. Ferrous just means that it has iron in it. Ferrum being Latin for iron, which is why we have Fe on the periodic table rather than Ir or something like that for iron, which Ir is actually iridium. But hey. So the rest of this arrangement, we have Har and Har are magnets. These magnets are not glued on or anything like that. They are merely magnetized and held on to the iron wire as such. Below them, you will notice there are some plastic cups here and here. You'll understand why we have those later. This somewhat less than wonderful weight is made out of styrofoam, and it is just that, a weight. It's a piece of styrofoam hanging on a couple of wires. You'll notice that it's sort of cut in half. I'll actually probably be clipping that into the video to show you what happened there, because that was fun times. And then last but not least, in the middle here, I have, this thing is called a variac. It is kind of scary looking. It's really not. All it does is it takes regular electricity you get from the plug, which is alternating current. Variac means variable alternating current, which means that with this dial here, I can change the voltage of the alternating current that is traveling through here. So out of your average outlet, you have 120 alternating current volts. I'm able to adjust it either down or, well, I can adjust the voltage down to do the things that I want to do at the speed that I want to do them. So, before we begin, let's do a little review. We have iron here. Iron is a metal, which means it has a crystalline structure. So what kind of crystalline structure does it have? Well, it's allotrophic. Allotrophic, just like when we worked with our sulfur. If you remember, allotrophic means that we can have the same element with multiple types of crystalline structure that it can form given certain features or characteristics of the environment in which it is forming. Now, give me a moment to disappear. Iron has two unit cell formations that we will be looking at today. So we have, if you guys remember, this guy. This is our body-centered cubic. This is the face-centered cubic. Boink. And how can I set that so you guys can see it? Maybe that works, sorta. Meh. So we have face-centered cubic and body-centered cubic. And FCC, BCC, if you do not remember, means face-centered cubic, body-centered cubic. Our face-centered cubic is the more dense of the two. See how if we put them next to each other, they take up about the same amount of space. The body-centered cubic takes up a little bit less, but not significantly so. However, in the case of our body-centered cubic, we only have 5 atoms in the unit cell, or actually 2 total, but we'll get to that. And in the case of this face-centered cubic, we have 5, 10, and in the middle we have 4, so 14 total atoms in this arrangement. So we have a much more densely packed arrangement in the case of face-centered cubic than we do with body-centered cubic. Moving on from there, I'm going to move these out of the way. And we're going to turn this thing on. Let's bring them into life or something like that. Except for, it is a good thing to have it plugged in first. It's a good thing to have it unplugged before you start, though. Turn it on, glowy switch. I'm going to turn this only up to 30 volts. We're going to see what happens. And you can kind of see a little bit better with the weight than with the wire that we are syncing. And if I turn this off, one thing that you guys probably can't see on this camera is that when I just turned it on, a little bit of smoke did come off. The reason that we had the wire smoke a little bit is these wires are coated in oil because they oxidize pretty easily. We'll get back to oxidation and corrosion and what those things are. So we had the wire lowered, and then we had it go back up. So why the heck did that happen? Well, I'm just going to do this again so that you can watch as I'm talking. As we run current through this wire, the atoms are picking up energy from the current. The wire is resisting the passage of the electrons through it. Copper is a much better conductor than iron, so as we have the current pass through it, we're losing energy from those electrons. The atoms are absorbing it, and that becomes vibration energy, and this is thermal energy. And what we have here is thermal expansion. So with thermal expansion, we have, as these atoms are vibrating more and more, they need to get farther away from each other. And as they get farther away from each other, the wire actually lengthens, making it sag. And if I go ahead and turn it off, the wire is now emitting the energy that it had in form of thermal energy into the surrounding environment because it is a conductor of heat energy. So it gives off the heat energy it has very easily to the surrounding environment. The atoms calm back down and we have it contract. So thermal expansion, we have the wire both expands in diameter and lengthens, causing it to sag. And then when we turn off the current, it goes back up. Da, 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 da. All right, now let's take it up a notch. I'm going to turn it all the way up to 60. And we're going to see some exciting things. Up we go, up we go. And you're going to start to see that wire real good. Now you can see where we have the magnets, there's dark spots on the wire. Now the reason for that is that these magnets are acting as heat sinks. They are absorbing the thermal energy from the wire, and so the thermal energy is going into these magnets, and even though the electrical current is passing through the wire past them, the thermal energy is being absorbed by them. I gotta be careful not to make something else happen. So if I turn this up just a little bit more, I'm gonna give it some. You can see those dark spots are contracting, and you can see on this one especially, it's starting to wiggle waggle. Why is it wiggle waggling? Wiggle wiggle. The other one begins to wiggle as well. Oh, it just dropped off. Why? And the other one's gonna drop right on target. So the thing is, iron has a special thing called a Curie temperature, and a Curie temperature is the temperature at which iron loses its magnetic properties or its ability to interact with these magnetic fields. And for iron, it is 1,403 degrees Kelvin. And for degrees Celsius, that's going to be 770 approximately degrees Celsius. So 770 Celsius, say that time. Nope, I can't say that 5 times fast, obviously. Now, what I want you to do is watch very closely how the wire moves as I turn this off. Oh, it didn't just go back up. It was sagging and it goes back up, but then it sags again to rise back up again. Now, if we only had thermal expansion, we would just have a nice, even rise back up. So what's happening? One thing that you probably couldn't hear that was happening as that re-sag was occurring is there's almost like a grinding sound that I can hear as after it rises, it sags back down. So I'm going to give you guys a second to pause the video and see if you can come up with an idea as to why this might happen, this weirdness. I will give you this hint though. My hint unto you is it has something to do with the allotropic nature of iron. Okay, if you pause the video, you were going to pause the video. If you haven't yet, then you had lost your chance. So, disappearing again, reappearing again, I'm a sorceress. It has something to do with these guys. So remember that in allotropes, we can have different crystalline structures occur when the environment in which the crystals are forming is somehow different. And typically, this has to do with temperature. This guy, this form of iron, is the one that is stable at higher temperatures. And this one at lower temperatures. So at some point during the course of me heating this up, we had a conversion from the body-centered cubic to the face-centered cubic. Now remember that in the face-centered cubic, we have a much more dense arrangement of atoms than in the body-centered cubic. Now as we're heating it up, this is happening sort of unevenly, I should say, across the entire wire, so we don't really see anything happening. But when we turn it off, we then reach the point where the face-centered cubic is no longer stable, and we have a solid state phase change to body-centered. Now the body-centered, we never lose any atoms of iron in this wire, but yet we convert to an arrangement of atoms that is far less dense than the face-centered cubic. So what that does is we have to expand in order to have this crystal structure form. Thus, we have, just like with our thermal expansion, we have a sag as the wire expands. That's why we get that double sag. Now, while I've been doing this, I'm going to turn this off. Something else has been happening. And what I'm doing right here is I'm crumbling whatever that stuff is off of this wire in a couple places. I'm just kinking the wire a bit. Ooh, That didn't feel good. We might have some more exciting stuff happen before I intended to. Prepare yourself. All right. So I just had some stuff crumple off right here. Whoa, I didn't mean to do that. Right here, 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 and here. Now I'm going to turn this on again after I get these plastic balls out of the way. I forgot I unplugged it again. Big surprise. There we go. Turning it all the way up to 60. See if you can see something weird. Huh. Those spots are glowing brighter. They're glowing a lot brighter. It's going away now, but what could have possibly happened? What could I have possibly done just by going like this? Breaking that stuff off that makes them glow brighter. I'm gonna turn this off for a hot sec. Haha, hot sec, I'm a punny person. So what do you guys think I was crumbling off of there? Something crumbly? What does that seem like? Something that might be on steel, something on maybe the bottom edge of your car or something after winter. Rust. Now this isn't rust per se. I'm going to unplug this before I touch this. This is something called scale. The only difference between scale and rust is, well, the number of atoms involved in a given unit cell of it. In the case of rust, we have Fe2O3. In the case of this scale, we have FeO. So what is rust? What is scale? It's crumbling off. It's insulating our wire. It's not allowing the heat to escape, which is why the wire isn't glowing as brightly as where I broke it off. What kind of material has those properties? It is brittle. It's an insulator. It's a ceramic. So we have oxidized this metal. Now, oxidation, essentially for all intents and purposes, means that it has reacted with oxygen. So we are surrounded by lots and lots of oxygen. It's the way we're able to breathe. So when we heat up this wire, it reacts with oxygen much more rapidly than if it was just sitting here. And I have some wire over there just sitting, and I can assure you it is not oxidizing. It also has oil on it to protect it, but that's besides the point. So we have oxidation occurring on this wire, resulting in the formation of a ceramic around the wire. And oxidation essentially just means we're reacting the metal with oxygen. Now, next thing I'm going to do is a little more exciting. I'm going to heat stress this wire. So I am going to heat it up, let it cool down, and we still have that solid state phase change that's so cool happening. I'm trying to decide where it's going to be, but I can assure you it will be here, 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 or here. Now, as I'm heat stressing this, I am forcing it to crystallize and recrystallize over and over again between the two states. What this is doing is it is slowly weakening the internal structure of the wire. I think it's going to be right here. Boy, that's really loud. You might actually be able to hear that grinding sound I was describing earlier. It's getting louder each time I do this. Yeah, I'm gonna go with this one right here. Yup, and little ball of iron just rolled across there. I'm going to shut this off. So it broke. We have it off. So as I'm crystallizing, recrystallizing over and over and over again this wire, we end up with the internal structure of the wire gets weaker and weaker with each pass until finally it goes to failure. So by heat stressing the wire, we have taken this wire to failure by inducing a bunch of defects in the crystalline structure. So that's all for today. I will see you all around.
The wire fell onto the cup once it broke. The wire cut through the cup. Is hot, very hot. Fe2O3?
Watch it. Oh, I just cut my weight in half. Well, that happens. Oh, that stinks. Okay, we're turning this off for a second, and I'm gonna show you what just happened. Well, I'm gonna come around, and well, you saw the wire broke, the wire dropped, but what you might not have seen is that the wire also landed on my weight, and it did that.